Alright guys, so let's look at the question we have on the paper, which is question 3. Now this is a series. We are on a series which is mole concept. So if you're coming across our video for the first time, do well to go back and watch the full video on mole concept so that you can be able to understand what we are doing here. Alright, so question 3 says, which of the following gases contains the least number of atoms at STP? Now option A, 7 moles of argon. Option B, 4 moles of chlorine. Option C, 3 moles of ozone. Option D, 1 mole of butane. So what we are going to do to get the correct answer for this particular question is to treat each of the options separately on their own so that we can be able to know the correct option for this particular question. All right, and for us to get that, we are going to write our solution. Now the first option is option A, which is 7 moles of argon. 7 moles of argon. You can make this capital letter, 7 moles of argon. The first thing you need to note here is that argon is a monoatomic substance or element, and what mono means is one. All right, so if argon is a monoatomic substance or element which is 1, then 7 mole times 1 is going to be 7 moles of atom. All right, so let's move on to option B, which is 4 moles of chlorine, right? 4 moles of chlorine. Now, chlorine is a diatomic substance or diatomic element. So if that is the case, 4 times 2. Mind you, when we talk about diatomic, it means 2. So if chlorine is diatomic, which is 2, 4 times 2 is going to be 8, all right? So 4 times 2 is 8 moles of atoms, all right? Now looking at option C, which is 3 moles of ozone. Three moles of ozone. Now, ozone is a triatomic substance, triatomic, and what that means is that it is 3 atoms of oxygen. So that is why it is called triatomic. And in nature, if it's triatomic, we are going to have 3 moles times 3, which is 9 moles of atom. And the last option is option D, which is 1 mole of butane, right? 1 mole of butane. So looking at butane, butane is different from these ones. So if you want to solve for butane, it is 1 times bracket. Now what we have here is 4 atoms of carbon and 10 atoms of hydrogen. That is our butane. And to get that, we are going to write 1 times bracket. Carbon is 4, so we write 4 plus hydrogen is 10. You write 10, bracket close, equal to what? Now if you calculate 1 times bracket 4 plus 10, it's going to give you 14. So we have our butane to be moles of atoms. All right, now look through this solving. If you look at option A is 7 moles of atom. Option B is 8 moles. Option C is 9 moles. And then option D is 14 moles. So which among these options has the least number of atoms? You are going to see that the one that has the least number of atoms is option A, which is 7 moles of atoms. So for that reason, the correct option for this particular question is option A, which is 7 moles of argon. Now let's look at question 4. Question 4 says, how many moles of limestone will be required to produce 5.6 grams of calcium oxide, and in bracket we are being given the mass of calcium to be 40, carbon to be 12, and oxygen to be 16. All right, the options: A is 0.20 mole, B is 1.12 mole, C is 0.10 mole, and D is 0.56 mole, right? So the first thing is to write our solution. Now the second thing we are going to do is to write out the equation that leads to this particular question for us to answer this question correctly. And the equation, the chemical equation, is this. This is the chemical equation that leads to this question, and this is what we are going to use to solve this particular question. All right, now number one, what is the molar mass of calcium oxide? That is what you are going to take note of. The molar mass of calcium oxide is what? Now the molar mass of calcium oxide is going to be what? 40 plus 16. How come we are writing 40 plus 16? How come? Now, calcium, remember that calcium is 40. The mass number of calcium is 40, and that of oxygen is 16. So that is why we are writing 40 plus 16. And if we add 40 plus 16 together, it will give us what? 56, right? So we have a molar mass of calcium oxide to be what? 56. Mind you that molar mass is always in what? Gram per mole. So our molar mass is 56 gram per mole. You can always write m.m, or you write it out as molar mass. It is still the same thing, all right? So the molar mass of calcium oxide is 56 gram per mole, right? So the second thing we are going to look at in this question is the mole of calcium oxide produced, because the question says how many moles of limestone will be required to produce 5.6 grams of calcium oxide. So we are going to look at the moles of calcium oxide produced. All right, so we write moles of calcium oxide produced. Now when we get to this point, you're going to think, which of the mole concept formula are you going to use to solve this particular question here? The right formula to solve this particular question is the formula that says moles equal to what? Mass over molar mass. This is the right formula that we are going to use to solve this particular question. And if you have moles to be mass over molar mass, that means it's going to be mass. Then what is our mass? Our mass in the equation is 5.6 grams. That is our mass. So you write out your mass to be 5.6 grams over molar mass. What is our molar mass? Our molar mass now is from here, is 56 grams per mole, right? So you're going to write 56 grams per mole. Now to get our mole, you are going to cancel out gram, right? So our mole is what? You can calculate the 5.6 over 56 is going to be 0.1, right? So you write 0.1 mole. This is our answer. If you look in the option that we are given, A is 0.20 mole, B is 1.12 mole, C is 0.10 mole, and D is 0.56 mole. So from our answer here, the correct option is option C, okay? Now let's look at question 5. Question 5 says the volume of 2.5 moles of oxygen at STP is what? Now option A is 50.0 dm cube, option B is 84.0 dm cube, option C is 28.0 dm cube, Option D is 56.0 dm cube. Now the question says the volume of 2.5 moles of oxygen at STP is what? So we are going to write our solution. The first thing I would like you to note at this point is that at STP, 1 mole of any gas occupies 22.4 dm cube. So at STP, 1 mole of any gas at all occupies 22.4 dm cubes. So if that is the case, 2.5 moles of oxygen at STP is going to be what? That is the question. So the first thing we are going to do is to think about the right formula that will give us the accurate and correct answer for this question. So the first thing you need to do is to take your mind back to the list of formulas that I gave out to you in the first video. And if you go through that formula, you're going to see the correct formula that we use to solve this particular question, all right? So that formula is mole equal to volume of substance over 22.4 dm cube. All right, but the question is asking for volume. The question says the volume of 2.5 moles of oxygen. So what are we going to do at this point? We are going to make volume of substance to be the subject of the formula. Okay, so how are we going to achieve that? We are going to cross multiply, and if we cross multiply, we are going to have volume of substance, volume of substance to be equal to mole times 22.4 dm cube. If we cross multiply, we are going to have volume of substance equal to mole times 22.4 dm cube. How do we get to this point? We are asked to look for the volume of 2.5 moles of oxygen at STP. Okay, so the formula that we are using says mole equal to volume of substance over 22.4 dm cube. But at this point, we are not looking for mole. What we are looking for is volume. So for us to get the volume of the substance, we are going to make the volume to be the subject formula. That is why we cross multiply, and when you cross multiply, we'll have volume of substance equal to mole times 22.4 dm cube. And if mole times 22.4 dm cube is here, what are we going to have? We are going to have volume of substance equal to, what is our mole? Our mole is 2.5 times bracket 22.4 dm cube, or you say times 22.4 dm cube. So if you calculate this, 2.5 times 22.4 dm cube is going to give you what? 2.5 times 22.4 dm cube is going to give you 56. All right, so the volume of substance is 56 dm cube. All right, so from our answer, let's look at what we have in the option. Option A says 50.0 dm cube. Option B is 84.0 dm cube. Option C says 28.0 dm cube. And option D says 56.0 dm cube. So from our own answer, the correct option for this particular question is what? Option D, 56.0 dm cube. That is the correct answer. Alright guys, let's look at question 6. Question 6 says, what is the molar mass of a substance if 0.4 mole of the substance has a mass of 25.0 gram? Let's read the question again. It says, what is the molar mass of a substance if 0.4 mole of the substance has a mass of 25.0 gram? Now look at the option. Option A says 62.5 gram, option B 40.0 gram, option C 6.3 gram, and option D 2.5 gram. So the first thing we're going to do is to write our solution. Now, what is the next thing you're going to do at this point? You're going to think about the correct formula that will help you to be able to answer this question. And if you go through the list of formulas that I gave in our first video too, you're going to see the correct and accurate formula that will give you the answer to this particular question. And what is that formula? The formula is mole equal to mass over molar mass. That is the formula that we are going to use to solve this particular question. But then in the question is asking for molar mass, right? So don't worry, we are going to solve the question. I'm going to show you how you can be able to make this molar mass to be the subject of the formula in this formula, all right? So since we are being asked to look for the molar mass, the first thing you're going to do is to make molar mass subject of the formula. And how are you going to do that? We are going to cross multiply. And if we cross multiply, we're going to have our molar mass times mole, because we are cross multiplying. Molar mass times mole equal to mass. Now, since we are being asked to look for the molar mass of a substance, we are going to divide both sides of this equation by the coefficient of molar mass. And if you check in this formula here, the coefficient of molar mass is mole. So if we divide through by the coefficient of molar mass, we're going to have molar mass times mole over mole equal to mass over mole, so that mole will cancel out mole, and we are going to have molar mass equal to mass over mole, right? So now that we have the molar mass equal to mass over mole, now let's impute our values. Let's impute the values. What is our mass? Check the question. The question says that the substance has a mass of 25.0 gram. So our mass here is 25.0. all right, so we have our mass to be 25.0 gram. Now what is our mole? You also check the equation. Our mole is 0.4 mole. That is the value for our mole. So we write 0.4 mole. Now let's calculate together. 25.0 divided by 0.4 is going to give us 62.5 gram per mole. Why are we having 62.5 gram per mole? That is our answer. Why are we having our answer in gram per mole? This is because the unit for molar mass is always in gram per mole. So that is why we are having 62.5 gram per mole. So if we look through the option that was given to us, you can see that option A is 62.5 gram, but then it is supposed to be in gram per mole because the unit for molar mass is always gram per mole, right? But let's forget about that. 62.5 gram, B is 40.0 gram, C is 6.3 gram, and D is 2.5 grams. So from our answer, which is 62.5 gram per mole, the correct option for this particular question is option A. We have our question 7, and question 7 says, how many atoms are present in 6.0 grams of magnesium? How many atoms are present in 6.0 grams of magnesium? And in brackets, we are being given the mass of magnesium to be 24. And the number of atoms, this is a constant, all right? So it's 6.02 times 10 raised to 23. In our options, we have option A to be 1.20 times 10 raised to 22, option B to be 2.41 times 10 raised to 22, option C 1.51 times 10 raised to 23, and option D is 3.02 times 10 raised to power 23. So the first thing we're going to do is to write our solution. Now, looking at this question, we are asked to look for the number of atoms present in 6.0 gram of magnesium. And for us to get that, the first thing we are going to look for is the moles of magnesium. Okay? So if you write out the values given to you, you notice that we are given the mass and we are given the molar mass. So if we want to get the moles of magnesium, we are going to use this formula which says moles of the substance, this is moles of magnesium, equal to mass over molar mass, right? So what is our mass? From the equation, our mass is 6.0 gram, right? So we are going to have 6.0 gram over molar mass. What is our molar mass here? Our molar mass here is the mass of magnesium. So we are going to write 24 gram per mole. So if you calculate 6.0 gram over 24 gram per mole, you're going to have what? Let's do that quickly. 6.0 gram over 24 gram per mole, you're going to have 0.25 mole. 0.25 mole. Now, why are we having mole? We are having mole because this gram will cancel out this one, and the unit for mole is always in mole. So whenever you're asked the moles of a substance, moles of magnesium, moles of any other element, the unit of that will always be in mole. So that is why we are having mole here. So our mole, the mole of magnesium is 0.25 mole. So now that we have our mole to be 0.25 mole, now we can go on and solve the question to get the answer, right? So doing that, we are going to write number of atoms, because the question says how many atoms are present in 6.0 grams of magnesium. So the number of atoms present in 6.0 grams of magnesium is what? So we are going to write number of atoms equal to, now the number of atoms is equal to mole times number of atoms, which is the constant. This is a constant. This number here is a constant in this equation. So the number of atoms is going to be mole times this constant. So you have times 6.02 times 10 raised to power 23. So if you write out the mole, you're going to have 0.25 times 6.02 times 10 raised to 23. Mind you to put your bracket, don't forget that. So 0.25 times bracket number of atoms, which is 6.02 times 10 raised to power 23. It's going to give us what? Let's do that together. 0.25 times bracket 6.02 times 10 raised to power what? 23. It's going to give us 1.505 times 10 raised to power 23. It's going to give us 1.505 times 10 raised to 23. All right. So approximately we are going to have 1.51 times 10 raised to what? 23 as our answer. So the number of atom is going to be 1.51 times 10 raised to 23. So looking at the options, we are going to see that option A is 1.20 times 10 raised to 22. Option B is 2.41 times 10 raised to 22. Option C is 1.51 times 10 raised to 22. And option D is 3.02 times 10 raised to 22. So from our own answer, the correct option is option C, because our answer is 1.51 times 10 raised to 23. So the correct option for this particular question is option C.